Hello students, welcome to my channel, and today I am going to explain you about moment of inertia of uniform rod. And for that here, so we consider uniform rod of length L and mass M here. First of all, I would like to calculate moment of inertia about an axis passing through center and perpendicular to its length here. So to calculate this one, you can see this is the center here and it is extended left side and right side by L by 2. So this is plus L by 2, this side minus L by 2 is there. So this is the axis here. Now in order to calculate the moment of inertia, I have chosen a small length element of mass dm. You can see here this shaded portion here, and its length is dx, and it is at a distance of x from the axis of rotation here. So this is the axis here. Okay. So first of all, we will define the linear density here. So linear density means what here? Mass per unit volume is called as linear density. So I am defining that one. So lambda equal to, we can write as mass by length so its value lambda equal to, we can write as m by L here. And now we have chosen a small length element. I said here its length is dx and mass is dm. So what is the mass of this length element here? So mass of length element is, that is dm. So you know total mass is what here? M. So unit mass is m by L. So what is the mass of dx length? So dx length is what here? Mass per unit length into dx. So we get as m by L into dx. This is the mass of that small length element. What is the moment of inertia here? General formula of moment of inertia. Moment of inertia of element of length element. So general formula you have to remember, I equal to mr square. This is the formula, general formula of moment of inertia, where m is the mass and r is the moment or perpendicular distance from axis of rotation. In this case, as we are choosing a small length element, I am writing di, its mass is dm and distance is x. So I am writing x square. You can see from the figure also, the distance is x here, mass is dm, so I am writing dm and x square. Okay. Now if you want the total one, that means the moment of inertia, the total rod, what we have to write? So moment of inertia of total rod I am writing here. So that is I equal to, I can write as integration of di. But what are the limits to be taken? Limits are very important in this one. So you can see the rod is extended from where to where here? Minus L by 2 to plus L by 2. So we can write the same limits here. So the limits are from minus L by 2 to plus L by 2, and I am writing di value, that is minus L by 2 to plus L by 2 dmx square. Let us substitute the value of the dm. It is m by L of dx here. So I equal to, I can write as integration from minus L by 2 to plus L by 2 m by L, this is dx into x square. You know this m by L are constants for given rod here. You take it out, right? Integration from minus L by 2 to plus L by 2 x square dx. Integration of x square is what here? X cube by 3, and I am writing the same, I equal to m by L, and this is x cube by 3, and substitute the limits here. First upper limit minus lower limit here. So m by L, I am writing the same. This x cube by 3 means L, in place of x you substitute L by 2. So what do you get? L cube, and 2 cube is 8 and 8 is 24. So I get L cube by 24, and minus, again this minus L by 2 is there, minus L cube, so it becomes minus of minus plus, so it is L cube again 24. So L cube by 24 plus L cube by 24 will be how much here? It will be L cube by 12. So ml cube by, this is what here, L is there, I am writing this is 12. So 1 cancel out L here. So we are left with what here? I equal to, we got as ml square by 12. So this is the moment of inertia of a uniform rod of mass m and length L about an axis passing through center and perpendicular to its length. Okay, so this is one. Now if you want the moment of inertia about an axis that is passing through one of its end, whether the right side end or left side end, no matter. So we are going to calculate that one here. Moment of inertia of a rod about one of its end. So moment of inertia of rod about an axis passing through one of its end. Okay, now so for this we are going to use parallel axis theorem. So what is parallel axis theorem here? Parallel axis theorem. Parallel axis theorem is used in this concept to understand this. What is this? I equal to ICM plus MR square is the formula. Where ICM is what here? Moment of inertia about the center of mass, that we got already, that is ml square by 12. And R is here what? The distance of that axis from the center of mass. So what is the distance of this axis from the center of mass, which is L by 2 here. So R value is L by 2 and ICM value is what here? I am writing the same here. ICM equal to ml square by 12 and here R value is L by 2. Substitute I equal to ml square by 12 plus m into R square means L square by 4 upon LCM and simplification we get the value as ml square by 3. Okay, that is I equal to, the formula is what here? ml square by 3. This is the moment of inertia of the rod about an axis passing through one of its end here. Okay, so let us see what we have done so far here. So we consider uniform rod of length L and mass m here. And our aim is to find a moment of inertia about an axis passing through center and perpendicular to its length. So for that, first we defined a linear density, that is a lambda equal to mass by length, that is lambda equal to m by L. So to calculate this uniform body, continuous distribution bodies, normally we take the help of integration. So for that we divided this rod into small elements each equal to mass dm and length dl here. Okay. So such one strip is taken, its mass is how much here? Dm equal to, because unit mass is unit length mass is lambda, the length of dx is lambda dx here. Okay, and its mass is now comes out to be what here? M by L of dx here. Okay, then what we have done here, we written the value of what here? Moment of inertia of this small strip here. So moment of inertia formula is what here? mr square, m is was, r is perpendicular distance from axis of rotation. So dr equal dm x square for total rod. We have integrated from minus L by 2 to plus L by 2 as the rod is extended from left side and right side by L by 2. We have taken minus L by 2 to plus L by 2. So upon integration and simplification we got I equal to ml square by 12. This is the moment of inertia of the rod about an axis passing through center and perpendicular to its length here. Okay, and if you want the moment of inertia about an axis passing through one of its end here, we have taken the help of parallel axis theorem, that is I equal to ICM plus mr square, where ICM already we derived, that is ml square by 12, R value is L by 2. On substitution we got this ml square by 3. Okay, So right guys, this is the value for this is for today. I hope you understand. Forget not to subscribe my channel and keep watching my channel for more videos. Thank you.